So, hello everyone. Good evening, everyone. So, welcome back to our this 30-minute session for this computer network. And in last session, we have understand the basic understanding of what is computer network and like different topologies, and we see mesh mesh topologies. Okay, network topology, node, VPNs, and VPN. What is different type of VPN? LAN, OSI layers, and OSI layer and TCP layer. Okay, what is router? Okay, so like we know that a router, DNS, SMTP. Router is a network device that is used for connecting two different network segments. Okay, but whereas in the cases gateway are also used as a route to regulate the network traffic, but they are send data between two dissimilar networks. Okay, so these are the things. We have HTTP. To understand what is HTTP, DNS is 53, SMTP is 25, HTTP 80, port number, HTTPS is 443, and like port number. Okay, where different type of layer. Why different type? What is the use of link layer, internet layer, transport layer? Okay, and when a physical layer, so in that case it's sent in the frame and packet. Okay, so it bits and frames, network packet, then TDPUP, like transaction protocol data unit, session protocol data unit, and the PDU, like presentness data unit. Okay, and then we understand what described OSM model. Okay, now we see that is the network. Okay, so now we see the see what is the difference between switch, router, and bridge. So what is the difference? Okay, the basic understanding is that different. The basic understanding for this one, what we have to say for this one, that is switch. Okay, so switch is like switch connect the various devices using a single LAN and MAC address. Okay, so this is a device. Okay, this is a device and this is also a device. So we want to connect this device and this device, so we can like use LAN and MAC. Okay, LAN and MAC. By using LAN and MAC, we connect the device is known as switch. Okay, and when we talk about router, so router connect different networks. So this is like set of one network and this is set of one network, but they are similar one. Okay, so in that case router is used. Okay, when we're talking about a bridge, so bridge gateway, so connect two different network segments. So in that case, to like connect two different network segments, like sound confusing, don't worry. So like I will explain the difference between them. So these three devices move the data, but they don't operate at the same level and the same purpose. Okay, so bridge work at the layer 2, that is data link layer. So bridge work as a in data. Okay, so this when we're talking about the bridge, so bridge work at the layer 2 and which is data link layer. Okay, and connect the two network segment. Okay, so it looked like that MAC address and the device like MAC address. Okay, it looked like the MAC address and the device whether to forward the filtered traffic. Okay, you can think like of it can be like early way to reduce the unnecessary traffic between two ports. So bridge usually have very few port and mostly consider predecessor and switches. Okay, now switch does something similar, like now switch does similar like something similar to the bridge but in the larger scale. Okay, so it is essentially a multi-port, so like it has few ports. So in when you talk about the bridge have a few port and considered as a predecessor of the switch. Switch does something that is better than bridge. It is essential having a multi-port bridge, we can say that, and it is work as a layer 2 and use the MAC address table to forward the frame only to correct device instead of broadcasting to everyone. Okay, switch, because the switch are the hardware level based, so have many ports and much faster as much efficient than the bridge, and this is why the switches are the most complete like that's this is why let have almost completely replaced bridge in the modern network. Okay, so what about the router thing? So router operate quietly different thing. Okay, so it work as a layer 3, one in the layer 3, that is the network layer, and use this IP address look instead of the MAC address. So its job is to connect the different network For example, your home network to internet. Okay, instead of using the MAC table, instead of using this MAC table, it it use the routing table to decide where to send the packet. Okay, so these are the like difference and this different layer. Okay, what is the different type of network delay? Okay, mainly the different type of network delay are the like propagation delay. Okay, transmission delay, and the processing delay. Okay, and queuing delay. So these are like different type of delay we see, like processing, transmission, like propagation, transmission, processing, and queuing delay. Okay, so let me explain. So I will explain everything in the depth so you can so you know the data travel from one system to another system almost every time you face a certain delay. So whenever we like sending this data from this device to this device, so we feel some like delay in this one. Okay, so this is possibly this process basically called the total delay or the latency, and it is made of a smaller delay, like a multiple smaller delay, like smaller delay big up to be like a bigger delay. Okay, so here is how it goes. First of all, what is the propagation delay? So propagation delay is a time is taken for the signal to physically travel from sender to receiver. So like this is the sender, okay, and this is the receiver, transmitter, and this receiver. So like it take a signal to physically travel from this sender to receiver, and now a propagation delay completely depend on the distance, okay, medium through which it like sending, and fiber, copper, all these things. Okay, and then come to your like transmission delay. So propagation delay is like physical everything, how like transmitter send to the end of receiver through copper, all this medium. And then we come out with transmission delay, that is a transmission delay, that is the thing. Okay, this is the time required to push all the bit of packet into the wires. Okay, so like we have like different bit, and this is the optical wire in which we have to send this data through the like at the end of this one. So the time taken to push all the bit inside this cable, okay, bit all into the cable. So if packet is large or like bandwidth is low, then the delay eventually increase. Okay, so this is mean like transmission delay. Now, once the packet is reach a router, it does not immediately move ahead, and there a small propagation delay, and where the packet check packet header and decide where to send. First of all, it is installed at this place. Okay, okay. At this position, first of all, we check the header file of this one. Okay, and first of all, we check the packet header and decide whether to send or next or not. Okay, so this time take a like processing delay. So this is the like processing delay, like checking all this thing, and this like pushing data into this one is like transmission layer. So even after everything is covered, there is still some time where the packet has to wait. Okay, so this waiting time is called queuing delay. Okay, so after this time, like this packet has to wait for something because it take like it's in the processing things. Okay, so this packet is delay, like this packet has to wait. So this delay is known as queuing delay. Remember that this is the most unpredictable one, and it depends on the network congestion. If any of this packet arrive at the same time, some of them to sit in the buffer and before being forwarded. So like these are the different type of networking thing. So here would you like note like bandwidth and latency. Bandwidth and latency are often confused with one another. Okay, so what is the difference between like what is the bandwidth and what is the latency? Okay, so you have to see this thing. Okay, so let's see so this is how you can differentiate it. Like bandwidth is like a number of lane for the highway. So this is bandwidth, so we can say this is like two lane. We can go from this area, and we can go this from area. If we extra increase this thing, again we go and came back. So like bandwidth is like a number of lane in highway, while latency is the speed limit. And If we have this area have a speed limit of 20, this area have a speed limit of 30, this area have a speed limit of 70. So this is the thing. And you can have the wide road like high bandwidth. This means that we have, if we high bandwidth, this means that we have number of lane to pass the thing, but the speed is low, that the high delay, and the thing still more like the thing still moves slowly. Okay, so we understand this thing. Okay, what a transmission propagation delay? Propagation delay is due to the physical like signal to physically transmit from the receiver end to like transmitter end. Okay, sender to like receiver end. Okay, so a completely different distance, medium, all this thing. This is known as this thing, transmission delay. So when we have about the like propagation delay, like when we talking about the transmission delay, in which like how much time taken to push all bit into the wire is known as transmission delay. So if a packet is large, like bandwidth, a packet is large or bandwidth is low, the delay eventually increase. So once the packet reaches the router, so it does not immediately move ahead. So for that thing, we have to wait for the processing. We have to check the header file, and then we have to send ahead. So in that case, it's a processing delay, and some of the packet has to wait in queuing delay. Okay. So what is ping command? So what is the ping command and what is TTL? Sorry, ping command and what is TTL? So here what you need what you need to remember is a ping. So ping command is given. So ping command is given because it is the simplest way to check if the system is reachable over a network or not. Okay. So but how does we check? So like ping command. So in Linux we mostly use for network and all this ping command. So if you want to check the ping of google.com, so in that case we have like in this terminal ping and that like website. Okay, that website. So it send the packet and we receive that packet. So in that process, how much time taken? If we send like 64 packet, we receive 63 packets. In that, like we have to lose like 0.22% loss. Okay, so these are thing are like explained by this ping command. So okay, this command is given because it's the simplest way to check the system is reachable over the network or not. Okay, so when you run this ping, your machine send a ICMP echo request to the destination. Okay, so in that this source send a ICMP request to the destination. This is the destination where it send, and then it will be received. So if the destination is reachable, it reply with the ICMP reply. Okay, by using ICMP reply. Okay, and so on. Ping is responsible for the two things. What are the two things we have like explain? Like these, if a system is reachable, so or just how long it took take time to like to reach. Okay, so first of all we have to explain that is the system reachable. So I am sending this signal and this is the like destination. First question that is the system is reachable? Yes, reachable. So how long it take to came back? Okay, that is the round trip. So go and again come back. So this is like a round trip. Now, along with this, every packet also carries something called TTL. That is TTL, time to leave. Time to leave, TTL. Or TTL is just like counter inside the IP packet. So TTL, we can say that it is just a counter. So we can say that TTL is just a counter or inside the IP packet. So every time the packet passes through the router, so every time we pass through the router, the TTL is reduced by 1. Okay, so if we change the router, so it will like TTL minus 1. So, okay, when it reached to 0, then the packet is discarded and the router send back ICMP the time limit exceeded message. Okay, so you might be wondering what is the need of this thing. Okay, so essentially because without TTL the packet stuck in the routing table and would keep circulating forever, and that is why TTL helps the packet to eventually expire. Okay, if we don't like put the like restriction on that packet, so it moves like is circulately moving forever in that table. So we have to like decide when it get expired. Okay, one thing you probably would notice that ping is the output like ping output is the TTL value. So ping output is a TTL value. The different system use different default TTLs. For example, Linux, Mac OS around 64 and Windows use 128 TTL, like TTLs. So sometime you can roughly guess the OS based TTL in reply or not. Reply. So when we look at this like a trace route, trace route and how it connect, how it connect, like trace route cleverly use TTL, like it send packet with the TTL of 1 and then 2 then 3. So each router drop the packet when the TTL becomes 0 and reply back. So this is how like map trace route map the path for the source and destination. Okay. And the voila that is like everything you can cover in a ping related question. But yes, then you follow up question in the into like if ping work but HTTP doesn't work, then what does it mean? So like what is the answer I have to give? If ping is working, that means that a destination is reachable. We can expect the answer. So it means that basic network connectivity is fine. The issue is likely to a higher level, for example, block port, service not running, application layer problem. So from the network side, it is good, but at the higher level, it is not like good. So we have to check at the different level. Okay, understand the ping. Now move to the next thing. How does SSL and TSL work, and what happened during TLS's handshake? Okay. So when we talk about the how SSL and TLS work, like SSL and TLS are the same and just the name is different. Okay. Currently people call TLS which stands for the transport layer security. Okay. And SSL is now the older version one. So like SSL is the older version one and TSL, that is transport layer security, it is like advanced version of this one. Okay. And the S from this one, the S from this S from this TLS is put into the HTTP. Okay, so interesting thing. Okay, now so TLS come in between of HTTP and TCP, and its main job is to make the connection secure. Okay, so that is the like for the security purpose this is using, and this make it encrypted, verified, and tamper proof. Okay, now the handshake happened before before any secure data is sent. Okay, so I will let you know that about in the simply. So stay with me. Look at the client which is the browser start by sending the message and saying which TLS version is support and which encryption method and cipher it can use. Okay, the server responds with the like chosen cipher and digital certificate. Okay, digital certificate, and this certificate contain a server public key and issued by the trusted agency CA certificate agency. And now they like only now they left now the only thing that is left is for client to verify this certificate. So first of all, like server send a cipher request which cipher is using. So it chooses a cipher and the digital certificate, and the digital certificate is like authorized by like biggest operator, that is CA. And now like a client verify that certificate. If it is valid, the both side is agree on the session keys, so that which will be used for the rest of the communication. After this take place, all the data is encrypted. So but how does it happen? So this happened by the asymmetric encryption, which is used during the handshake to secure the exchange key. Okay, and symmetric. So how this happens? So first of all, the asymmetric encryption is used during the handshake to exchange the key, and then symmetric encryption is used after that because it is faster for the transfer. Okay, faster for the data transfer. Remember that TLS 1.3 is improved. This is because by reducing the number of round trips established the connection. Okay. So like what is SLS? How does the SLS work and how like happen in handshake? So we know that. So what is VLAN? We have studied earlier. That is what is the virtual LAN and what is the use cases. So I have to like moving fast. Like VLAN is a way to divide a VLAN is a way to divide a single physical network into the multiple logical network using the switch. Okay, so it is a way of dividing the single network into the multiple logical using the switch. Okay, and even though all devices may be connected to the same switch, VLAN make it work as if they're a separate. So like, so what is the thing that even though all the devices may be connected to the same switch, the VLAN make it work if they are like separate network. Okay, so okay, to understand it is better, so you should think of the LAN. So in the regular sector, all devices connected to the switch. Okay, all devices is connected to switch because it is a large port and it is working on the second layer. So all devices connected to this switch. Okay, and switch connected switch belong to the same broadcast domain. So it belongs to the same broadcast domain. Okay, these like same broadcast domain. So any broadcast message like ARP, address resolution protocol, is sent anywhere. So now here what VLAN does. So basically all devices are grouped into the different LAN. So each VLAN act as its own separate network. So if we provide this VLAN to this node, so it act as a different separate network. Okay. So for here the broadcast traffic stay with VLAN and does not reach other. Okay. Another interesting part that is device in the same VLAN can communicate as if they are on the same LAN. Okay. So interesting thing is that the device in the same VLAN can communicate if they are same like LAN. Okay. Even they are connected through different physical switches. Okay. This is possible because VLAN information is carried across all the switch using this, like this is the port and VLAN ID is standing from this one. Okay. So why VLAN is actually used? So it is used with the use of VLAN, grouping become possible based on this function instead of the physical location. For example, there can be an HR department in one VLAN and engineering in another line, and this mainly help to improve the security, reducing the broadcast traffic and making the network manageable and more flexible. Because of this uses, most switches use like VLAN 1 unless it configured the otherwise. Okay, VLAN is even like VLAN divide the single physical network into multiple groups, and like in that group which can they communicate. So these are like divided because to improve the security and reduce the broadcast traffic and making the network more flexible and visible. And the next thing, that is what is the proxy server. So what is the proxy server and forwards proxy and the reverse proxy? Okay, this thing, like proxy server act as an intermediary and middleman between the client and server. So this is the client, this is the server. Okay, and this proxy server act as a middleman between this one. Okay, so so what happen if the direct communication does not take place? So and a request is passed through proxy. So if we send a request, so it has to pass from this to this thing. Okay, so which is then forwarded to destination where it is intended to set. Okay, now the proxy work differently and depending on where it is placed. Okay, so and this can be understood through the forward and reverse proxy thing. So first I will explain this you to that in a simple idea, that is we have like different. First all, normally a request goes to, like normally we have client and we have server. So okay, so normally a request goes from the client to server side. Okay, but when the proxy is introduced, the client first nudge the proxy. Okay, then when the proxy is introduced, the client first nudge the proxy and then reach to the server. So you have to go and then after to go this server. Okay, in forward proxy, the proxy sit in front of client. So the request flow goes from client to forward proxy and then internet. Okay, and because of this, the server doesn't really see the client by using this. Because of this, server doesn't really see the client ID. Okay, client IP address, instead of only they confront the proxy. Okay, so whenever the website is needed to control, like the corporate setting, the forward proxy is used. Okay, and it can be also be used for the caching and hiding the user identity. So proxy is like a wall for the client to hide their identity and use for the caching tools. Okay, and now we talk about the another thing, that is the reverse proxy. So reverse proxy, what is reverse proxy? So consider in the opposite case here, the proxy sit in the front of the server. Now proxy sit in the front of the server. So, and because that flow goes a client, then serve that, and then to the reverse proxy and then server. So like now in that case, like this is like client and this is like proxy server and this is the server. Okay, so like server in sit front of this, like any proxy server, like reverse proxy server sit in the front of this one. The flow will client, then reverse proxy server, and then the server. Okay, so from the client viewpoint, so it look like they are communicating with this single server. Okay, single server, but internally the proxy may be routing are like multiple like request to a multiple backend server. So let's the client is thinking that they are like requesting to a single server, but it is connected to the multiple servers. Okay, okay. So this setup is usually used to for the load balancing, SSL handling, and the protecting the server from the direct exposure. Okay, so it is so in the most scene, what you remember is that the proxy server, like forward proxy, is used for the client side hide. Okay, and client identity in the reverse proxy is used on the server side, which hide the server's identity. So for example, we can say that forward proxy are often used for the like cooperate with the firewalls. Okay, as I explained earlier, this forward proxy act as a firewall, and the reverse proxy is commonly used to like a neg nginx and cloudflare, all this thing. Okay, so we understand different two type of proxies. So let's see another question. So what is port number, and what do you mean by this port number? So what are the port number and what are the well-known port number? So like IP address. So like first of all, the IP address work well with the like machine and the system. IP address work with the machine and system, but it does not necessarily tell you which application or service or the machine must handle the request. Okay, so when we like IP provide this address, we know that tell that it work well with the machine and the system, but it don't tell at which application it's serving. Okay, and that is why the port number is used for that purpose. Okay, so basically the port identify the specific process and the service running on the host. So like we are IPs, so if to work well with the machine and the system, so we know that this is a machine, this is the system. Okay, but we don't know that what application this we are doing on this machine and the system, and what the task or the request is handling. So for that case, the port number is important. The port number identify. So in that case, the port number, that is stick to here, like port number is identify the specific process and services running on the host. For example, if we have like 192.60.168.110.443, so this is 443. Okay, and this is 10. So in this device, and 443 tells the like system to route the request to the HTTPS services. Okay, and the combination of IP address and the port is called socket. This combination of the IP address and this is IP address and this called as a socket. So we call as socket, and it is uniquely identified as the communication endpoint. So port number can be divided into the range of groups. Okay, so we know it. This one 0 to 10, like 0 to 1023. So well-known port, which is like which are the system level services, services. When we move to 1024 to like 400, all the register level ports, and this is a dynamic ports. Okay, so well-known port that you keep in our mind. So first of all, HTTP, that is 18. HTTPS is 443. FTP, we are talking about the controlled one is 21 and the data one is 20. SSH 22, Telnet is 23, SMTP is 25 as we discussed in the last session. SMTP is like 25. What is DNS? DNS is like working on the 53 where dynamic host configuration, all this thing. 67 and 63, okay. 67 and 68. POP3 for the messaging, 110. IMAP 143, SNPP 161. One more thing that is like not studied, that is we write HTTP is 80. So we write here. So DNS, we see that DNS is 53, SMTP is 25, HTTP is 80, and HTTP is 443. So these are covered in this thing, okay. So why is port number is important and what is common. So like also, so also remember the TCP and UDP to handle the port. So for the port 53, DNS can work over both TCP and UDP, okay. So you can ask this question, ask this question and follow up during interview. Can two services use same port? So you can answer not on the same protocol but at the same time, okay. So I have answered not on the same protocol but the same time. However, like TCP 80 and TCP UDP are treated as a separate but both working are the simultaneously, okay. Okay, so now we have to explain what is subnetting and what is CIDR. What is subnetting and what is CIDR? Like subnetting means that dividing the network into smaller part, and the subnet help in like subnet is dividing this network in a smaller part. So we have this network, okay. So we have to divide into smaller parts. So this is known as subnet. Network subnet is and subnet help in division where it tells which part of IP address, which part is the IP address and which part is the host, okay. For example, if we use /24, which means that the first 24 bit of this network bit are for the network and 8 are remaining for the host, okay. So we can understand from this question. So if someone write this thing, this IP, okay, this 24, okay, /24, if is the colon is 443, this means that this is used for this like port number. If it's /24, it means that which part, like it division. So total address is 256, outer usable part is like 254, okay, and outer usable part is 224. But why not 256? It is because that .0 is a network address, so and .25 as a broadcast address. So network address and this .0 is the network address and .25 is the broadcast address. So we left with 254. So we have 254 are left. The broadcast address. So actual IP usable are this one, like from starting from the 1 to 254. Now if we slip and now we have 254 and now we have to split into 24, okay, into the smaller network. So you can increase the network by 25 and you can increase the network bit by 25. So we have to write like this thing, okay. So this will give a two subnet like 0 to, okay, 0 to 27 and second part is equal to this part, okay. Okay, so and how when it happens, so each subnet get a fewer host and this segmentation get better. So now here is some quick info you need to keep in our mind about the subnetting. So it reduce the unnecessary broadcast traffic, okay. So it will have to like reduce the unnecessary broadcast traffic, improve the security isolation between the network and use IP address more efficiently, okay. And some common CIDR value that we can should that you should remember, that is high, that is /8. So /8 represent like common CIDR 255, not this one, okay. 16 mean that 255. So 24 this thing, okay. Single host is a single host slash 24 like 32 is the single host. Okay, and these two questions are like I have to like these two questions are the last two questions. So what is NAT? Okay, so what is NAT and why it is used? So first of all, NAT is a network address translation. Network address translation. So NAT is the network and is a networking technique that is used by the router and is that used by the router and so that a private network or like a private network on the multiple devices, so private network on the multiple device can be shared a single IP address to access the internet. Okay, so when the multiple private network working on the different multiple devices, so it might be sharing like same IP to access the internet. But why it is needed? So like so device inside a network use private IP which are not directly accessible over the internet. So when a request is sent out, router replace the private IP with own public IP. Okay, this is the private network. So whenever I send a request to this router, so router first of all replace this private IP with the own IP. Okay, and when the response is came back, so this is device, this is router, it convert that private into the public IP and response is sent back to this user side. Okay, so the router use mapping to forward to the correct device. Okay, so this mechanism especially become necessary because the IPv4 addressing are limited. Okay, and that is why instead of assigning the unique public IP to every device's NAT is made so that the multiple device could share a single IP. We should also note the different type of NAT. Okay, so instead of assigning the unique IP, okay, instead of assigning the unique IP, so that NAT made it so to it that multiple device should be share the single IP address. Okay, there's two type of IP, that is static, that create a fixed one-to-one mapping. We can say that we have two IP. The static one is fixed one-to-one mapping like between private and the public, which is usually for the server. Okay, and where dynamic with pool of the public IP is assigned then when needed. Okay, so now like fixed one-to-one mapping and the dynamic is the pool of mapping. Okay, so but even so the most commonly used from the PAT, also known as like is most commonly uses PAT and is known as NAT overload. So PAT is like a PAT, like multiple device share the same IP and connection are distinguished using the port number. Okay, port address translation. Okay, like router map internal IP and port combination a unique external port, then help the multiple connections simultaneously. So the external system also directly initiate the communication with the device like private unless the additional configuration like port forwarding, all these things. So and this limiter is one of the many reasons that why we use like IPv6 was design and where can device can have like globally unique address and NAT is not required. Okay, so can you explain, well, this is the last question that in today's session, can you explain the TCP three-way handshake in detail? Okay, so before getting into the detailed answer, first of all we have to remember the three word, that is sync, acknowledge and then acknowledge. Okay, so talking about the TCP, before my data is sent over the TCP, first of all client and server is expected to make sure that the connection is established. Okay, so like this is my server like client and this is the like server. So okay, before like sending data, first of all we have to establish the connection, and in this case TCP use three-way handshake method where it establishes the connection where both sides are ready to send and receive data. Here we go. So a client say your browser to want to connect to the server, so it start by sending a sync packet. So it send a sync packet. Okay, So like along with this, it include the initial sequence. Basically, I want to start the connection. Here is my data numbering begin. Okay, so these are like acknowledged thing that I have sent to this like browser like server side, and the server side receive that response with the like receive this response with the acknowledge sync and the two things that are like then sync and acknowledged sync and acknowledged. Okay, this segment. The two things that take place, it acknowledge the client sequence number and also send its own sequence number back. Okay, like first of all, we are connecting. Okay, first of all, I tell that this is my I want to like start the connection with you, and this is my initial packet number. So it is a sequence of my packets, and server also agree with this thing. Server also agree with these things and tell that okay, I have acknowledged your request, and this is my like initial sequence number, and send its own sequence number back to the client. And then the client send its final acknowledge confirming that it received the server sequence number at the point. So in that case, like server send client said acknowledge. Okay, at this point the connection is established and data transfer begins. So and after that the data transfer began in this one. So you might wonder why three steps are required here instead of two. So and it is because the both side need to be confirmed two time. Okay, both side will be like confirmed two time, and that is why we can send and that, and that is so if they can send or receive things. Okay, with only two step. So the server couldn't like know if the client actually receive its response or not. Okay, once the communication is done, the connection is closed. Once the communication is like done, the connection is closed in four steps. First of all, finish, finish, acknowledge, finish signal, then acknowledge signal. Okay, then finish acknowledge signal. So which is slightly more involved. So that here is what you might to get asked during the interview. What happen if sync acknowledge is lost? So you answer the client wait for the timeout and then retransmit the sync knowledge. So if like there is a timer, so if like if this server if a client send a acknowledge signal like sync signal, so and he also send a sync acknowledge signal. Okay, acknowledge signal, but sync acknowledge signal lost. So like this client has to wait for some time and again retransmit this sync signal. Okay, what is the sync flood like sync flood attack? So it is when an attacker send a large number of sync requests but never complete the handshake. So this leave a connection half open and can exhaust the server resources. Like is sending the sync request. So attacker send a large number of sync requests, so never completed to the server. So it will affect this server side. So this is what a three-way handshake in TCP. So in further lecture, so we will do like question like related. What is the IPv6 and what how it is different from the IPv4? This is the like one of the most important question asked by this interview. What is IPv6 and what is IPv4? Okay. Then then okay, this is the last question. Okay, we have to finish this question. Okay. So like Internet Protocol version 6. So IPv6 is known as the Internet Protocol version 6, and it is popularly called IPv6, and it is updated version of the IP addressing and slight like might sound silly, but the main reason is to launch because IPv4 ran out with this ran out of this address. We have seen that for that's why we are using NAT Very sorry for inconvenience. Where we are. So like internet protocol version 6 is popularly known as IPv6. Okay. So because the main reason it launched to this IPv6 is that we ran out this address things IPv4 and IPv4 use a 32-bit address. Okay. And gave roughly 4.3 unique combination. Okay. So it give a 4.3 billion unique combination at that time it sound like lot, but with a phone number, laptop, IoT device ended up not being enough. Okay. So hence IPv6 was introduced to solve this problem by the 128-bit addressing. Okay. So this is 32-bit, this is 128-bit, which is written in the hexadecimal format, which look like this one. And with this format, the almost unlimited space is created, so every device would have its own unique IP, and also this is why the IPv doesn't rely on the NAT or this IPv. That's why the way the IPv4 is doing this. So we spoke about this space, but there is more to their differences. So IPv6 make the packet header simpler than the IPv4 did, like making the routing efficient. Okay. And reducing the unnecessary traffic become important. Like reducing the unnecessary traffic is important. The IPv6 replaces the broadcasting traffic with the multicast communication, and you must third thing is that you must also note the another important thing about IPv6 is that it is built in IPC support, IPSEC support. So it is useful because it is make easier to have a communication with the protocol level with IPv6. The communication protocol at the IPv6. Okay. And you also noted that the IPv6 supports something called auto configuration, so which is also known as SLAG. Okay, SLAG. This means that the device can create their IP address without needing the DHCP server in many cases with this IPv6. Okay. So here, where do they both stand currently? So basically, IPv6 hasn't fully replaced IPv4. Instead, they are working together for a dual stack setup. One thing you must not forget here is that both systems don't communicate directly. They require a translation mechanism like a dual stack, tunneling, or NAT64 to work together. Okay. This is all about the IPv6. Okay, IPv6. So we have studied all the question that is important in this computer network. So we come with checklist in the next session. So whoever would need this PDF, just comment. Okay. So I completed everything that is most important things. Okay. So thank you for joining this session. Goodbye.